This video is still working in Chapter 9. We're in the Pythagorean Theorem chapter, and we're working in Section 9.3 on special right triangles, more specifically 45, 45, 90s. So let's take a look at an example. Let's look at example B. And we can see it's a 45, 45, 90. The first thing you should do when you look at a right triangle problem is determine if it's a special right triangle, and if it's not, then you're not going to use the special right triangle ratios. Those are reserved for either 30, 60, 90 triangles or 45, 45, 90s. So I can see that these are both 45 degrees because this is 45, that's 90. They have to add up to 180. So I've got my isosceles right triangle. So I can see these two sides are congruent. So since I know one of the legs, I know the other leg is also going to be 5 root 2. Now, you could calculate that using the ratios. That's perfectly fine. But if you're given one of the legs of this isosceles right triangle, you automatically know the other leg. So we know that the ratio of the sides in a 45, 45, 90 is 1 to 1 to root 2. All right, so this side gets a 1, and this side gets a 1, and this side gets a root 2. And since we already determined that y was 5 root 2, we just need to find x. So I'm going to do red over black. So I have square root of 2 over x. And then red over black for this leg is going to be 1 over 5 root 2. And then we'll cross multiply. So I have x times 1, which is x, and then 5 root 2 times root 2. So I get that x is equal to 5. This is root 4. The square root of 4 is 2, so that's 5 times 2, or 10. All right, so if that went a little bit fast, feel free to rewind and rewatch. It's only a couple of minutes. Make sure that you're putting the numbers over here by the triangle so I can see where you're putting your ratios, numbers for your ratios. And make sure you get help if you need it, and we'll see you in the next video.